It's time! In the red corner. No, jokes aside, welcome back to Next Generation Threats. We're in the breakout track. And I hope you guys had a great lunch and that you have some energy so you're ready to listen to the next speaker. So please give a round of applause for Olle Segerdahl. He's a principal security consultant at F-Secure. Woo!
Hi, everybody. As Marcus kindly said, I'm Olle. I work as a security consultant with F-Secure. And I also help make a security podcast, Swedish language one, which is called Säkerhetssnack. So I encourage you all to check it out if you speak Swedish. So I always have to start with this slide. I've learned that F-Secure, well, F-Secure is a product company everybody knows, but not many people know that F-Secure also has a wide range of security services, including consulting services, which, as I said, I'm a part of. So I just have to start with that so that you're not all wondering when is he going to start talking about antivirus, because I'm not. So I'm going to talk about security and development practices and how that works with agile development processes. So agile, first of all, was a reactionary movement in the software development community that focused on providing customer value. And the agile name came from the idea that in order to maximize customer value, you had to be able to quickly adapt to changing requirements and changing circumstances during the development, recognizing that no customer ever knows exactly what the customer needs or wants at the start of a project, for example. And agile methodologies are not always, but often cited as problems in the security community. And what I'd like to talk to you about today is more how can we harness the power of agile development methodologies to enhance security? So how can we make these practices actually support software security? And this picture is something that you've probably seen before. This is the so-called waterfall model of software development practice. And I think this is kind of a bit of a straw man argument to see that people are still using this as like an anti-pattern or a counterpoint to agile development practices. I think nobody actually works this way, that you start by gathering all the requirements and then you do all the design, and after you've done all the design you do all the implementation, and after you do all the implementation you do all of the testing. That just doesn't really happen because it doesn't work in practice. So if you take the end node and the start node of this waterfall and you connect them together, you get something more like a circle. And this is more what real software development looks like, is that you always iterate and you can jump back and forth between these. It doesn't have to be a whole revolution each time, but this is basically how all software development works in agile and in less agile development practices. And different practices, different development methodologies allow for different speeds of iteration around this circle. So each revolution of this you can think of as like an agile sprint iteration or something like that. And in less agile methodologies, you might take longer to go from planning a feature to building it until you push it out into production. Whereas, for example, we work with companies that push code changes into production several times per day, and they run this circle, tens of times per day. And basically, what we're talking about here with security in terms of agile is security cannot be a roadblock to this. It cannot slow this movement down. Otherwise, developers will just see security as a stumbling block, as a roadblock, something to be avoided, something to be routed around. So we need to help developers build secure software without slowing them down. Because there's value in being agile. There's value in being quick. There's value in being able to react quickly, for example, to new threats, to be able to react quickly to attacks when they happen in production, to be able to produce code fixes for security bugs quickly and being able to push those out into production quickly. There's big security value in that as well. So how do we do that? That's the big question. How do we get security into an agile development process without doing it the traditional way, where you insert some kind of security testing when you've done your implementation, you have some kind of acceptance test from security mandated before you're allowed to go into production with that new code, for example. And that's a typical example of something that developers don't like for several different reasons. It's not just because it's a stumbling block on the way to releasing something into production that slows them down. It's also because there's a large amount of uncertainty for the project in that they're not really sure if they're going to pass this test. And how are they going to be able to, for example, plan development resources for fixing the stuff that comes out of the test? Say that the security testing produces a list of security bugs that need fixing. Then how do we gauge how much fixing time we need to plan for between this security testing event and the actual release into production? You can't really do that because you don't know what's going to happen. So how do we build security into more of the development practice? So one thing that's extremely helpful, and I encourage you to check out Window Snyder's talk at 3:20 today, she's going to be talking about this, is when you're planning a feature, when you're planning what you're about to implement, write down the top level, high level architecture of what you're about to build. Try to put names to things and map out data flows between components. Try to get a sense of what you're building. And then have a brainstorming session and try to find out what are the probable attacks. Where are the points where you could actually have security problems in this design? As I said, I'm not going to go into too much detail on this process. I think Window is going to cover that pretty nicely. But this way, you can find out where in your design do you need to add security controls. And then you can capture these as security requirements for the feature that you're planning to build. For example, by describing them as evil user stories or abuse cases, counterpoint to the user stories and use cases that you normally work with when planning a software feature. And you could also think of it as security stories, as in I, as a security professional tasked with monitoring this application, would really like to be able to trace what a user has done in the application, for example, accessed which patient data records or wherever the application might be handling. So you can make a security story around that when somebody accesses for example, patient data record, there should be some way of seeing after the fact that has happened. Another thing that's extremely helpful is what I call security engineering. So this is all of the stuff that when you're actually planning to build those security features. One thing you always should think of is how can we reuse features between not just different places in our application, but also perhaps between different development teams in the organization if you've got more development teams. Because if you're building security components that can be reused, you can scale the efforts you put into making those components as secure as they can be, instead of distributing those testing or other security spending you're doing on those code components. You can more efficiently create secure components if you're actually reusing them between projects or between development teams. One goal of security engineering should always be to make it hard for the developer to create security problems when actually implementing features and programming. So these components could, for example, be, let's take the really easy example of SQL injection problems. If we build a secure component that we know doesn't have those kind of problems because it accesses the database layer in a secure way, and we can, by, for example, testing or inspection, make sure that all our code features use this component to talk to the database, then we can kind of effectively say that we've eliminated the problem of SQL injection. And this goes for other types of security controls as well. So that's kind of what I mean is instead of everybody being tasked to write secure database access code in all parts of the application, make sure everybody uses the same functionality and make sure that functionality is as secure as it can be. Another thing that's really important when designing security or security engineering is the concept of multiple reinforcing controls. So, for example, why are modern web browsers so hard to attack? We see these figures from Pwn to Own each year that people are getting huge amounts of money for being able to successfully compromise a modern web browser. Why have they become so secure? Well, it's because you have several different methods that are hindering the attacker in several different layers. So you might not be able to rid the application code of bugs, but you can make it harder for somebody to abuse one of those bugs. So for example, by memory corruption mitigation technology. And once somebody is, despite those technologies, able to abuse the bug, you can have another layer, which is a sandboxing layer, which means that you're restricting the privileges you actually obtain by exploiting the bug. So if you have these multiple different layers or reinforcing controls that stand between the attacker and their goal to compromise the information stored in the application, for example, then you can actually make sure that even if you have one bug somewhere along that chain, it doesn't compromise the whole integrity of the application. And then the last thing in developing for security, verification testing. If you know what kind of controls you need because you've done architecture analysis or threat modeling, and you've built secure components that implement these controls, then it kind of becomes easier to create security tests as well. If you task a developer with creating security tests, they might not really know what they're supposed to be covering with those security tests. And it's a constant problem to try to build some kind of a standard of what is enough testing during development. Because remember, we can't defer all the security testing until the end of an iteration, because then we've got this gating function again that slows down development. We've got to be able to do security testing, create security tests while we're developing features. And we've got to be able to run those tests during development so that we're reasonably confident that our code passes the test, the code is reasonably secure before we push it into production. Because we remember, we've removed that gating function of the security acceptance test. So everything we push into production, we better make sure that it's secure enough to be able to release. So to be able to do this kind of testing during the development cycle, and to be able to say that the stuff that we've built and tested is reasonably secure, then we need to build a system for testing. So the one thing that we need to do most of all is automate all the tests. We can't have a human performing interactive tests because that slows down development cycles, and also it creates a barrier to actually running the tests. If you've got fully automated tests, then you can run them in as many times as you like, or as many times as you can spend CPU cycles on. Whereas if you have interactive tests that requires a human in the loop, it becomes a barrier to testing. So the test won't be run as frequently, and then you don't get as much value from them. So when you're designing your security tests, you should really focus on providing as quick feedback to the developer as you can. So if you can create a test that actually runs, for example, in the compiler, or when the developer is checking in new code to the source control system, that gives a very, very quick feedback to the developer that, oh, you didn't use the secure component for accessing the database, for example, or you made this mistake that somebody's made before that we've put in a test to make sure that we never make again. And if you provide quick feedback to the developer, there's a much better chance of this bug not making it into the actual application. And of course, it also gives a reinforcing feedback to the developer, so the developer will be better over time. They will learn not to make these mistakes again. Also, of course, it will probably be more cost-effective in the long run if you fix bugs early, or not even create bugs in the best case. So that kind of drives both developer improvement and efficiency of the development cycle. Then I said something about agile methodologies earlier, being able to contribute to security by making it possible to react quickly to attacks. So if we're going to have the goal of reacting quickly when an attack happens, then we have to have more than a rapid development cycle that can react quickly by producing a software patch for a security bug. we also have to be aware that there is an attack underway. So another thing you have to do is plan for that ahead when you're developing your applications. So you have to create visibility into what's happening in the application. One quick thing that you can do in pretty much any application system or platform is that you can start by collecting logs. So most systems have some kind of logs that are security relevant or useful for detecting attacks. Maybe not access logs of exactly what's happened in the application. So for example, in a web application, you won't typically have full logs of every request that's being served by the application, because in, for example, web post requests, you won't save all the post data, so you won't have full visibility in what's happening in the application. But you do have exception logs, for example. You do have error logs that are very useful to collect, not just to find security incidents, but also to find something that might be wrong with the system, just accessibility-wise. Of course, that only gets you so far, as I said. It doesn't give you full visibility into what's happening in the application. So what you can do then, as a next step, is to start instrumenting your code, to start putting hooks into, for example, the database layer to find weird stuff happening there. In error handlers, typically, any kind of exception handling system you've got in your application is prime for putting inspection hooks into. And of course, you can provide that full visibility into the application and what's actually happening in there, because remember, we kind of wanted that anyway to provide traceability into seeing what user has accessed what information at what time. We can use the same kind of instrumentation to collect all that data and run security analytics on it to see if there's actually something that looks out of the ordinary that could indicate that an attack is underway. And then, of course, how do we react quickly when we do see something out of the ordinary? Well, you have to plan for that. You have to have a response procedure in place so that you know who's going to do what are the lines of communication between the different parts of the organization, or different organizations even, who might be involved in responding to an attack. And of course, make sure that you can quickly run through the development cycle to produce a fix for a particular security bug that you found in production. Then, of course, you have to have a quick deployment procedure to get those fixes out into production. And one thing that we talk about is actually rolling forward with fixes. What we mean by that is that once you've pushed new code into production, it might take weeks, months before you actually find that bug, or somebody else finds that bug for you. And by that time, you've already created lots of new features, new code, that you don't want to roll back to the previous state to eliminate this bug. So what you want to do is you want to fix the bug and deploy that along with all the new functionality, because it's okay to deploy new functionality into production because we're reasonably sure that we've created it in a secure manner with all our security tests that we've got implemented during the development process. So that's why we talk about rolling forward instead of rolling back deployments. And I also promised to talk about some organizational issues around this. I don't have a lot of time for that, but I will be here for the rest of the day. If there's anything that sparks your fancy here or you want to talk to me about, please don't hesitate to come and talk to me later on. So one thing that's important for software security is making sure that it doesn't become attacks on development teams. So if you've got an organizational structure where you're essentially punishing a development team for doing security work by having it, for example, be an internally debited function within the company, where you have to get your security work done by this security group over here, and then you have to pay them an hourly rate, for example, internally within the company, then that essentially becomes a tax on the development team and makes it less likely that they are going to do security work. So one way to actually embed security work into the development teams is by the concept of security, having a security champion on the team, which is basically one person who might 20% of their time, for example, be tasked with coordinating security efforts, being that point of contact between the development team and the security organization, and of course also being the interface for coordinating development efforts between development teams if you've got more than one development team and you want to do stuff like sharing secure components like we talked about earlier. And that person can then be the one who's tasked with keeping track of the security work, planning the security work in for each iteration, software development iteration, for example. So that kind of ends up at this concept of security agility that was my made-up title for the talk, and where we can work together across different organizational teams to deliver safe products in a development flow that's continuous, that doesn't depend on stopping with these quality control gates or whatever, and using organizational and technical tools to be able to respond quickly to incidents when they actually do happen and fix them in production. So that's kind of wrapping up everything I've said here today. So I don't think we have too much time for questions. Maybe we can take one. If there's anybody. Do you see a hand?
No, but they can hunt you down later.
They will hunt me down later. Yeah, definitely. So thank you very much.
Thank you.